Alright guys, this is Unit 5, Lesson 8, the last lesson of this unit. And today we're really going to be talking about modeling with systems of inequalities. Again, just dealing with word problems. But a lot of times you guys ask, like, when are we going to use this math? This is sometimes where a lot of businesses use the exact math we're going to be doing to help model what their business should be doing. So it's kind of what this is saying. Good little paragraph here to read. So let's look at exercise number 1. It says John mows yards for his father's landscaping business for $10 per hour and also works at a bakery for $15 an hour. He can work at most 52 hours per week, and he needs to make at least $600 per week to cover his living expenses. So part A wants to say, if John worked 14 hours mowing and 30 hours at the bakery, does this satisfy all the problems of his constraints? So you should be able to answer A by yourself. So hit pause and give that a try and see how you do. So do that now, please. All right, how did you do on part A? So hopefully you did something like this. Basically, we did 14 times 10, because he worked 14 hours for $10 an hour. He worked 15 hours and got paid he worked 30 hours and got paid $15 an hour. That this combined total was supposed to be more than 600, because remember, when we say at least 600, that's the least amount. We could go over 600, but we can't go less. So then you would just solve this, so it should have been pretty easy. And when you added this up, you only got 590, which is not greater than 600. So these hours were not enough for him to meet his living expenses, so that's not good. All right, part B, we want to see if X represents the hours John spends mowing and Y represents the hours he spends at the bakery. Can you write a systems of inequalities to describe the scenario up top here? So again, you're trying to write your own system of inequality, and see if you can do that now, please. All right, what did you come up with? So for my first equation, I have something like this. X plus Y has to be less than or equal to 52. Because remember, X represents just the hours John works of mowing, and Y represents the hours he spends at the bakery. And remember, it says that if you were to take those hours and add them up, his mowing and his bakery hours, that at most he could work 52 hours. So he can't go more than 52. 52 is the most, but he can work less. So that's why this is inequality. It doesn't say he has to work 52. And then what about here? Now, when we're talking about dollar amounts, now we have to put the dollar amounts with the actual costs. So, or the dollars with the number of hours. So he gets paid $10 an hour for the mowing hours and $15 an hour for the bakery hours. And again, that has to be at least 600. So it has to be 600 or more. So that's basically the system I came up with. Hopefully you did okay with that. And let's move on to part C here. Okay, part C says, if John must work a minimum of 10 hours for his father, will he be able to make enough money to cover his living expenses? Show how we got our answer. So he must work at least 10 hours for his father. Would he make enough money? So go ahead and give that a try now. Okay, how'd you do on this one? So first of all, remember his hours had to be, if we added them up, had to be less than 52 hours. And we have to do at least 10 hours for the mowing. So I put 10 in here and just figured out, okay, if he's doing 10 mowing, he must do 42 at the bakery. So now we could take these numbers and plug them into our other equation, which is over here. There it is. So 10 hours for his dad at $10 an hour. 42 hours at the bakery for $15 an hour, and then we just solve this up, and there we go. So he could work 10 hours for his dad and still make enough money to meet his expenses. All right, part D wants us to graph this. Now we don't have to be specific because we don't have actual grid lines, so it just wants you to kind of do a sketch of one, and you can use your calculator and plug them in and let that kind of see what it looked like. And remember, you could use the shading on your calculator. However, be careful. Before we graph these, remember that these equations must be in the y-intercept form, or the slope-intercept form. So it'll kind of help you out with that. So remember, what we want to do is get the y by itself, so let's get rid of that x by subtracting it from both sides. And when we do that, we get something like this. If you want to write 52 minus x, that's fine also. The other one a little more difficult, but still, here's our other inequality. We got to get that y by itself, so I subtract the 10x first. Remember, you can't separate those, so I just wrote negative 10x plus 600. You can't combine those. And now I'm going to divide by 15. There we go. And finally, here is the inequality that we have. And there we go. So now you should be able to graph both of these. So put them in your graphing calculator and graph it on the space provided. So give that a try now, please. All right, let's see what your graph looks like. So hopefully yours looks something like mine here. So this first one in red, I knew that the intercept was at 52, so I kind of just estimated there's 52. And the slope was going basically down 1 over 1, so it's like a perfect diagonal line here. And so there's my first equation. I labeled it. And it says y has to be less than or equal to, so you can see these red lines are below it. On the other one here, the intercept was 40, so it was below 52, and again, you just kind of had to estimate where 40 was. And this one was going down at like minus 2 over 3, so negative 2 over 3, so not as quite steep. And again, you probably saw that on your graphing calculator. And so here's the other line. Doesn't have to be perfect, but something relatively that way. And you could see where the interlapping is right here. So that would be your solution area where it's in both regions. Okay, so we're moving on here. All right, now for part E, it wants to know, and I want you guys to, again, try this on your own. John's father needs him to work a lot at the landscaping business. Show the point on the graph that corresponds to the greatest number of hours that he can work and still cover expenses. So what's the greatest number of hours he could work for his father and still cover expenses? Can you find that on the graph? So do that now, please. Make a point somewhere. All right. Let's grab the graph, and hopefully you could understand what I put here. So you can see the yellow is the overlap. Now, I find the greatest number of hours, here's hours, so we track that across the x. So if we looked at the x value here, we could come up and see that this point is in the region, so that's good. So this amount of x hours is enough, but we want to find the maximum. So I'd keep going as far as I can. Now this point is right here. That's the x value for this point. That's kind of the intersection point, which we're allowed to since we have solid lines, so we can equal that amount. Now, if I tried to go more hours and I went to the right, this amount, we'd have a point maybe here in the red, we'd have a point here in the green, but look, we're outside of our region where we need for our expenses. So he's can't work both these amounts, so he's only could satisfy one of the, but not both of them. So this is the maximum amount of hours mowing. As I move to the right, this is the only one that would the farthest to the right in the yellow region. Hopefully that makes sense to you. So that's the point we're looking for right there. All right, now algebraically find the greatest number of hours John can work and meet his expenses. So basically solve this algebraically, just like you've learned. So give that a pause and try to solve this system. All right, now you could solve it with substitution. I thought the original way was set up perfectly for some elimination. So if you look at the purple here, this is the original system that we wrote. Everything is kind of lined up. So if I multiplied by negative 10, I could start canceling things out. So that's what I did here. As you can see, I have exact opposite coefficients. So when I'm done with this, I get something like this. Then I divide. And notice that when I multiplied by negative 10, it made me switch that inequality sign so they all match up. So remember, when you multiply by a negative, you got to switch the sign. And now I find that y has to be greater than or equal to 16. But y, remember, is the number of hours of bakery I want to find out for mowing. So I can take this y amount and plug it in. Still pretty easy here. So my y is 16. So now I just solve for x. And therefore, the way you read this is X has to be less than or equal to 36. So the maximum hours he could work for his father is 36 hours, and he would still cover his expenses. So he can work less than that, meaning he would work more of these, but this is the maximum amount of hours he can make. Or work, I'm sorry. All right, moving on. Okay, I got to speed this up just a little, so make sure you follow along, hit pause if you need to. So exercise 2 is going to be difficult for you guys. Some of you maybe. So you're basically going to write a system of inequalities for each of these scenarios. You do not have to solve them, so that will save you some time. So read the whole thing, be careful, these are tricky, and see if you come up with a system. So try that now. All right, so let's see how you did. For part A, pretty tough. Did you come up with this one right over here? Okay, there was actually 3 parts of this system. Now, since it told you these R's, R represents the number of roses and D represents the number of daisies. That was important. Well, what do you know about the number of roses? Well, it says there must be at least 1 rose. So the number of roses has to be greater than or equal to 1. So that is a statement they said. You represent it with math. What must we know about the daisies? Well, you must buy at least 2 more daisies than roses. So the number of daisies is greater than the number of roses plus 2. So there we go. And then for the total value, you must spend 40 or less. And remember, the value means you take the number times the price. So the number of roses times $4 plus the number of roses or number of daisies times $2. That's how you get the value. Must be less than or equal to 40. So that's how we came up with that. If you want to hit pause and try B again, because you could see that maybe this would help you, you could do that also if you want to relook at your answer to B. And let's see how you did on B. So for this one, you would do something like that. Now again, this one was hard because there was a lot of different words going on, but look at this. X represents the weight in grams of protein, and Y represents the weight in grams of fat. Now what do we know about the weight? It had to be at least 10. So if we took the weight of one plus the weight of other, that had to be 10 or greater. Okay. Then it told us the total calories. So now we had to apply calories to those numbers of weight. So 4 calories plus the weight and 9 calories plus weight. If we added all that together, it had to be less than or equal to 100. So again, kind of difficult. Hopefully you did okay on those. Okay, let's move along. Whoops, well, I didn't cover the answer. So I just messed that one up. But oh well, not a big deal. So read the problem, see if it makes sense to you. I think you guys would have came up with this just fine. So I'm going to let you hit pause and just read through the problem and check my answer, see if it makes sense. So pause that now and read it. All right, so you can see they have to sell at least 500 tickets. So the number of tickets together has to be less than or equal to, or there's 500 tickets total, so you can't go over 500. And they wanted to make more than 2,000. Again, the dollar value means the number times the price. All right, now I didn't mess this up. You guys go ahead and try to graph this one. And remember, to graph it, you have to move things around before you could really put it in there. So give that a try. Put this in the y equals form and then see if you could graph them. So do that now. All right. So hopefully you rewrote these and put them in the y equals form so you could see that's what they look like right there. So check your equations, see if you have those. And your graph should come up looking like something like that. I didn't do the full shading, but you could tell it has to be greater than, whoops, let's switch over here. This line's greater, so these are going up. These ones are going down. So this is the region here that we want to get our maximum values there. All right, and finally part C. So go ahead and read this. Now it says exactly 500 and exactly 2,000. So you don't need to do inequalities. You can say equals 500 and equals 2,000 and write a systems of equations and try to solve that. So go ahead and see if you can do part C here. All right, how did you do with this? So part C, basically you set up your system. I multiplied everything by -5 to get some perfect opposites you can see hopefully. And when I solved this, I kept going and I got y is equal to -100, but we had to find both, so I plugged that in, found my x value, and then it said, why is this not realistic? Well, what does this mean? That means we'd have to sell negative 100 tickets, and that doesn't really make sense. So that's